So today we are going to continue with more two-step equations. There's still two steps involved, but there's a little bit of a different approach to it because of how they're laid out and what symbols are used. If you need to look something up, this would be Chapter 6, Lesson 5. So I want you to look at our first example. We've got 3 parentheses x plus 5 parentheses equals 45. Now, we're still going to split them at the equal sign, and that's our 2 halves. Let's look at the left for a second. I want you to think of this as 3 times something. I don't even care what's inside those parentheses. It's 3 times a chunk of stuff. All right? Now, what happens if I replace that chunk of stuff with a variable? And you know a variable can be a letter or a symbol. So what happens if I do 3 times triangle equals 45? Think way back to when we first started studying equations a couple days ago. How would I get rid of that 3 to have just the triangle by itself? Well, I would divide, right? Because this is 3 times triangle. So we divide by 3 and divide by 3. Triangle must equal 15. Whatever that triangle is 15. Now, maybe that triangle was x plus 5. Maybe that triangle was x plus x plus x. We don't know. But I want you to kind of keep that in mind as I start to show you how to do these problems. Now, take that away for a second. Most of you would probably try to distribute, and you get 3x plus 15. And you could solve it from there, right? 3x plus 15 equals 45. Subtract 15, divide by 3, divide by 3. Awesome, you'd get x equals 10. But guess what? That's a 3-step problem. That's a 3-step problem because first step was to distribute, and then you had 2 steps over here. So if you're not a big fan of showing work in math, let's avoid that because it just gives you an extra place to make a mistake. Now, let's bring in what I first showed you as 3 times stuff and why I can simply divide. This is really 3 times whatever happens to be under my finger in the parentheses. So if it's 3 times stuff, let's just divide by 3. Now, 3 divided by 3 gives me 1. Whatever's under here, I don't care. It's not divisible by 3 because I've already taken care of that. So whatever under my thumb gets rewritten. And then the other side, 45 divided by 3 is 15. That's one step. Now I've got another step to get x by itself. How do I undo plus 5? With subtraction, of course. So I get x equals 10. The same I got the other way. Now, after we get through this particular lesson and you're presented with one of these, I don't really care which method you pick. Both of them get you the right answer. Both of them are mathematically acceptable. Just do it. If this is happier for you, go for it. If this is happier for you, do that one. Okay, let's go on to another example. Same idea. All of these are going to be a number with parentheses. So you're going to do a lot of the same kind of steps today. The only difference, now we've got some negatives or some subtractions. So we're going to have to be a little bit extra careful. So 5 times something equals negative 30. Well, let's divide by 5. If I don't write on my finger here, that would be good. Because that will get rid of the 5 over here. And then I'm left with whatever's under my thumb and whatever negative 30 divided by 5 is. 30 divided by 5 is 6. There was one sign, so it's negative. Now, how do I undo the subtraction? With addition. So I get n equals negative 4 because these were different. So I subtract, keep the number with the bigger pile. If you do your check step, and I highly encourage you to do that, go back to the original as it was written. Because what if you made a mistake in here? If you try to go back to this step, that's not going to be very helpful. You've already made the mistake. So go back to the very, very original when you replace to do your check. This time, I do think I'm going to do order of operations. Okay, I do think I'm going to do inside the parentheses. So change, this would be negative 6. I'd have 5 times 6 is 30 with one sign. And would you look at that? Both sides equal negative 30. So my answer of negative 4 is correct. All right, I got two more answers, or two more questions for you, two more examples. This one has a fraction. Nothing changes. We're still going to do the same steps. I've got 2/3 times stuff. So I'm going to divide by 2/3. But ew, dividing by fractions? No, thank you. What can I do instead of dividing? I can multiply by the reciprocal. So I'll multiply by 3/2. Multiply by 3/2, give that a denominator. On the left side, the 3 and the 3 and the 2 and the 2 leave me with just one whole. That's 6/6. So I'm left with n plus 6 on the left. On the right, I'd end up with 30/2, right? 10 times 3 is 30. 1 times 2 is 2. This will simplify down. Think about a clock. 30 minutes, cut in half, 15. One step to go. We'll undo the addition with some subtraction. And I end up with n equals 9. And then if you want to check real quick, 2/3 times 9 plus 6, does that equal 10? 2/3 times, I'm going to get rid of the parentheses for this part, 9 plus 6 is 15/1. And I get 30/3, which indeed is 10. I guess I should go to the very final step. There. Makes my math brain happy. This is kind of unresolved. And then one final example. Yeah, I got to throw some decimals in there. You got it. Nothing changes. We're still going to divide by the number out front. In this case, 2/10. I'm left with whatever was in the parentheses. Most of us are going to reach for a calculator, and that's totally okay with me. 10 divided by 0.2 gives me 50. I could have tossed in a negative sign. And you just said, wait a minute, I divided and I got a bigger number? Well, yeah, because this is like $10 with a bunch of coins that I'm splitting into piles of 20 cents each. I'm going to have a lot of piles. And it's negative, which just means you owe it to me. And then I'm going to undo subtraction with some addition. Because they're different, I'll subtract. Keep the sign of the bigger number. And there you have it. So in all of these, you're going to divide by the number. It's not really a coefficient because it's not solely with the variable. It has to be solely with the variable to be considered a coefficient. So you're going to divide by the one factor out front, and then whatever's in the parentheses is left over for your last step.